Hello students, my name is Professor Muhammad Asim and we are doing AdMath. AdMath for IGCSE students which have syllabus code 0606 and for CIEO level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we finished a very important chapter, chapter number 15, name integration. Today we are going to start another very important chapter, chapter number 16. The name is kinematics. This word kinematics is not new for you. This is very familiar as O-level AdMaths students, science students. You did lot of work in physics which is related to kinematics. So when we heard the word kinematics, we must have some terms in our mind like displacement, distance, velocity and acceleration. These are the combination, and the combination of these words makes kinematics. It is the branch of physics which deals of the particle when particle is in motion. So we are seeing the use of derivatives and integration in this chapter. The first topic of this chapter is, you can see on your screen, applications of differentiation in kinematics, or you can say the use of derivatives in kinematics. So first word which you can see on your screen is displacement. What is displacement? Displacement is defined as the shortest distance between 2 points. It is a vector quantity. What is vector quantity? A quantity which associate both with both magnitude and direction. Consider a particle P traveling along a straight line such that its displacement s meters from a fixed point O means origin, t seconds after passing through O is given by s is equals to 4t minus t square. The graph of s against t for 0 to 5 seconds. What does it mean? Whenever we draw the graph of time against displacement or displacement against time, we must take time on x-axis and the displacement on y-axis. So you can see this curve. It is start from 0. So when time is 0, then the displacement is 0. I am just reading the graph. I will draw when I do exercise 16.1. When time is 1 second, the displacement is 3. When time is 2, the displacement is 4. When time is 3, the displacement is 3. When time is 4, the displacement is 0. And when time is 5, the displacement is minus 5. So vector quantity can be positive or negative. So this is the graph of s is equals to 4t minus t square. Okay. So whenever you draw the graph, you must have t is positive because time cannot be negative. Okay. This can be represented on a motion diagram as follow. So this is the graph, and below the graph it is a motion diagram which is very important. students always feels difficulty in motion diagram, but with few important points which you must keep in your mind, you can easily draw the motion diagram. See this line, a number line from -5 to +5. This line represents S. S means displacement 0, 1, 2, 3, 4, 5. So at t is equals to 0, you can see the displacement is also 0. It means nothing, no change. At t is equals to 0, the displacement is also 0. At t is equals to 2, you can see at t is equals to 2, the displacement is 4. This is graph, and in motion diagram you can also see when t is equals to 2, the displacement is 4 meter. You can see this one. Focus this cross. At t is equals to 2, the displacement is 4 meter. At t is equals to 1, the displacement is 3 meter. When t is equals to 2, the particle stops instantaneously and reverses its direction of motion. You can see on this graph, at t is equals to 2, the displacement is 4, but after t is equals to 2, the direction has opposite, the direction has changed. So we also in our motion diagram we also change the direction. So at t is equals to 3, the distance is 3. Okay, sorry, the displacement is 3. So in this diagram we have to obtain distance with the help of displacement. I am shortly explaining the meaning of displacement and distance. See this. Suppose that we have a point A and we have a point B. Let's suppose the shortest distance from A to B is 5 meter. So it is called a displacement. But how many ways to go from A to B? There are so many ways. For example, this one. For example, this one. For example, this one. For example, this one. So there are 1,000 ways to go from A to B. But the shortest way to go from A to B is a straight line. So this straight line represents the displacement, and all others line represent the distance. So distance is always greater. For example, if I say a point is moved from A to B, the distance is 5 meter. Sorry, the displacement is 5 meter. But from B to A, the displacement should be -5 meter. The total displacement when goes from A to B and from B to A, the total displacement is 0 meter, because -5 plus 5 is cancelled. But the total distance is 5 plus 5 is equal to 10 meter. This is the difference between displacement and distance. Distance is a scalar quantity. No concept of minus sign in distance. But displacement is a vector quantity. If you start from point O, does some distance and reach again point O, after some time the displacement is 0, but the distance is the total from one point to another point and another point to one point again. Now come to our motion diagram. So at t is equals to 2, the particle stops instantaneously and reverses its direction of motion. At t is equals to 3, when time is t is equals to 3, the displacement is 3 meter. Obviously, you can see the displacement, you can see on the displacement distance, displacement time graph. At t is equals to 3, the displacement is 3. But what is the total distance? The total distance is, first, from 0 to time t is equals to 0, t is equals to 1, displacement is 3. Then at t is equals to, displacement is 4, and at t is equals to 3, the displacement is 3, and at t is equals to 4, the displacement is 0. But the total distance is, you can see, at time t is equals to 3, the displacement is 3 meter, but the total distance is from 0 to t is equals to 2 is 4, and then reverse from 2 to 3, from 2 to 3, the displacement is 3. Therefore we have to subtract 4 minus 3. So, or you can directly write, from 0 to t is equals to 2, the displacement is 4, and then from t2 to t3, the displacement is from 4 to 3, that is 1. So total distance is 5 meter. So at t is equals to 3, the total distance is 5 meter. At t is equals to 4, at t is equals to 4, the displacement is 0, obviously, because it reaches the initial point. But the distance, the total distance is, at t is equals to 4, the total distance is 4 plus 4 meter, because from 0 to t2, the displacement is 4. From t2 to t4, the displacement the displacement is 0, but the distance is 4. Negative 4 is no concept in when we talk about distance. So 4 plus 4 is 8. Hope you understand. Now t is equals to 5. The displacement is minus 5, obviously, but the total distance is, you can see, from t is equals to 0 to t is equals to 2, 4, and from t is equals to 2 to t is equals to 5. You can check. So 4 and 4 plus 9. Why? Because from negative 5 to positive 4, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total displacement is 4 plus 9 is 13 meter. This is total displacement from 0 to 5. 0 to 5 seconds. So this is called the motion diagram. Very easy, very important. Now, velocity and acceleration. The rate of change of displacement is called the velocity. Velocity is a vector quantity, but in differentiation can also provide the velocity. If you differentiate displacement with time, you will get the velocity. So the formula of velocity is ds upon dt. It means derivative of displacement with respect to time gives us the velocity. And you know what is acceleration? Acceleration is defined as the rate of change of velocity. So if we differentiate velocity with respect to time, or if we take the double derivative of displacement, we will get acceleration. So in the light of this concept and see this important table, signs for displacement. First one is if s is greater than 0, something to the 0 less than 0 means it is negative. So we have to say that point P is to left of O. S is equals to 0, it means point P is at O. S greater than 0, it means point P is to the right of O. Greater than 0 means positive. Signs for velocity. If velocity is negative, it means it is left, moving left. V is equals to 0 means P is instantaneously at rest. This is very important point. And when V is greater than 0, P is moving to the right. Signs for acceleration. When acceleration is negative, it means velocity is decreasing. When acceleration is 0, it means the velocity is either minimum or maximum or to be constant. And when acceleration is positive or greater than 0, it means velocity is increasing. So in the light of these concepts, we are able to start exercise 16.1. See question number 1, exercise 16.1. Question number 1, part A. A particle moving in a straight line passes through a fixed point O. Its velocity v meters per second t seconds after passing through O is given by v is equals to 50 upon 3t plus 2. So the velocity is v is equals to 50 over 3t plus 2 whole square. Part A. Find the velocity of the particle as it passes through O. What does it mean? What I showed you, passes through O means, look at this table again. A very important table is given in your book. Signs for velocity. So at v is equals to 0 means time is 0. So passes through O means at rest. So t is equals to 0. Okay. So put t is equals to 0 in the question. 50 upon 3 into 0 plus 2 whole square. 50 upon 3 into 0, 0. 2 square is 4. 50 upon 4 is 12.5. 12.5 meters per second. This is the answer of part A. Part B. Find the value of t when the velocity is 0.125. Very easy. Just replace the value. Just replace v by 0.125 is equals to 50 upon 32 plus 2 whole square. So 32 plus 2 whole square is equals to 50 upon 0.125. 400. Taking square root on both sides, so 3t plus 2 is equals to 400 square root is 200. 3t is equals to 200 minus 2 is 198, and t is equals to 66. But I will check all steps again. Sorry, one mistake. Square root of 400 is not 200, it is 20. And 20 minus 2 is 18. And 18 upon 3 is 6. So 6 second is the answer of part B. So you can see how easy these questions are. Find the acceleration of the particle when t is equals to 1. So part C is v is equals to 50 upon 32 plus 2. What is the formula of acceleration? If v, first we have to write this 50 3t plus 2 power minus 2. So dv by dt, derivative of velocity with respect to time, 50 into minus 2 is 100. 3t plus 2 power minus 3 minus 100 upon 3t plus 2 power 3. This is the acceleration, but the requirement is to find the acceleration A at t is equals to 1. Minus 100 upon 3 ones are 3, 3 plus 2 whole square. Minus 100 upon 3 plus 2, 5 whole square is 25. I am checking again, is there any mistake? Yes, I forgot to multiply the derivative of the function, that is 3. This is very important. So I have to write over here 3. So 3 into 100 is minus 300. So it is not 100, it is minus 300. So minus 300 upon 25 is and this is minus 3, and I wrote 2. This is not good. This is 3. So 3 plus 2, 5. 5 power cube is 125. Kindly ignore my mistake. Minus 2.4 ms minus 2 is the final answer. So hope you completely understand question number 1. Now move to question number 2. What is question number 2? Question number 2 is a particle moving in a straight line passes through a fixed point O. Its velocity v meters per second t seconds after passing through O is given by v is equals to 6 e power 2t minus 2t. Part A. Find the initial velocity of the particle. So initial velocity means we have to put t is equals to 0. Always put t is equals to 0 when the requirement is initial, that is initial distance or initial velocity or initial acceleration. So v is equals to 6 e power 2 into 0 minus 2 into 0. V is equals to 6 e power 2 into 0 is 0 minus 0. 6 into e power 0, something power 0 is 1 minus 0. So 6 meters per second is the initial velocity. Part B. Find the initial acceleration of the particle. Very easy. Write v 6 e 2t minus 2t. Find the acceleration dv by dt. 6 e power 2t derivative is e power 2t into derivative of its function, that is the derivative of 2t. 2t derivative is 2 minus 2t derivative is 2. So 2 6 are 12 e power 2t minus 2, and initial acceleration means a when t is equals to 0. 12 e power 2 into 0 minus 2, something to the power 0 is 1, so 12 minus 2 is 10 . 12 minus 2 is 1, so 12 minus 2 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 into 0 is 0 minus 0 . 6 e power 2 ms minus 2 is the answer of acceleration of part B. So very easy question. Hope you completely understand. Looks very lengthy but very easy question. A particle starts from rest and moves in a straight line so that t seconds after passing through a fixed point O, its velocity v meters per second is given by v is equals to 5 into 1 minus I think it is e minus 1. Part A. Find the velocity of the particle at t is equals to ln 100. Sorry, this is obviously this is t. This is t. So t is equals to ln 100. So v is equals to 5 into 1 minus e minus t. T is ln 100. V is equals to 5. 1 minus ln and e cancel. Minus minus plus. Kindly wait. Sorry, I did a mistake. Minus t. T is ln 100. So 1 minus e. It is the property of logarithm that power can be written before the log and after the log. So it is ln 100 power minus 1. So v is equals to 5. 1 minus. Now ln and e cancel. 100 power minus 1 can be written 1 upon 100. 100 ones are 100. 100 minus 1 is 99. 99 upon 100. 5 into 99 upon 100 is 4.95 meters per second. Okay. Part B. State the value which v approaches as t becomes very large. Very easy. T becomes very large means 5. V is equals to 5. 1 minus. It is e power minus t. So for example, if I take t is for example 10,000. For example, okay. So if I find the value of 1 minus e power minus 10,000 is the answer is the whole answer is 1. 5 ones are 5. So for the value when t is becomes very large, the value of v must be 5 meters per second. Hope you understand. Part C. Find the acceleration of the particle when v is equals to 4. So v is equals to 5 1 minus e minus t. Here v is 4. So replace v by 4 is equals to 5 1 minus e minus t. 4 divided by 5 is equals to 1 minus e minus t. 4 upon 5 is 0.8 is equals to 1 minus e power minus t. So e power minus t is equals to 1 minus 0.8. E power minus t 1 minus 0.8 is 0.2. Taking ln on both sides, ln on both sides, ln e power minus t is equals to ln 0.2. Kindly wait. So ln and e cancel. Minus t is equals to ln 0.2 or t is equals to minus ln 0.2. So if you find from your scientific calculator minus ln 0.2, your answer is 1.6. But this is not our answer. Our target is to find the acceleration. So v is equals to 5 into 1 minus e power minus t. So for acceleration we have to find the derivative. So 5 into derivative of 1 is 0 minus e power minus t is e power minus t into derivative of minus t is minus 1. 5 minus minus plus e power minus t. So 5 e power minus t. T we have find 1.6. Therefore our answer is 1.000. It is round off. So we have 1 meters per second square. This is the answer of part C. Very easy. Part D. Sketch the velocity time graph for the motion of particle. Very easy. First we have to draw x and y axis. This is x axis. This is y-axis. On x-axis we have to plot time. This is the origin, and on y-axis we have to plot v. Okay. Now at 0, see this, 1 by 1. At 0, your answer is 0, because v is equals to 5, 1 minus e power 0. So something to the power 0 is 1, and 1 minus 1 is 0, and v is equals to 0. So the first point is, I will use another color pencil. At 0 times 0, the value of v is also 0. And at t, the value is something less than 5. At t is equals to 2, 3, 4, 5 and so on. But in part B, you have find the value when v approaches as t becomes very large. So answer of part B is 5. This is our answer of part B. So it means when we increase time again and again and again and again, the velocity of the particle is maximum at v is equals to 5. So if we draw a dotted line, our graph would be closes and closes and closes and closes to 5, but not equals to 5. Okay, almost 5 but not 100% equals to 5. So this is the answer of part D. Hope you understand question number 3 as well. Very important question and very easy question. So student, this is our today's class where we did introduction of chapter number 16 and also we did first 3 questions of exercise 16.1. How many questions are left? 4, 5, 6, 7, 8, 9, 10, 11. 11 questions. So 8 questions are left. I will try to finish this whole exercise in next 2 lectures. So I request all of you kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos as many as you can. Okay students, good luck for next lecture.